Now, in this question, we want to figure out the orbital hybridization around the central carbon atom in this chemical right here. Now, in order to do that, we have to figure out what the Lewis structure looks like. And to get the Lewis structure, we need to know the number of valence electrons in each of the atoms in this chemical compound right here. And to do that, we're going to need a periodic table. So let's pull up a periodic table. So here's a picture of the periodic table, and what you need to know is everything in this column right in here is going to have 8 valence electrons, except for this helium right here, and that's going to have 2 valence electrons. Everything in this column right here is going to have 7 valence electrons. Everything in this column right here is going to have 6 valence electrons. Everything in this column will have 5 valence electrons. Everything in this one will have 4. This one right here will have 3. And we're going to skip this part and come over here, and this column right here will have 2, and this column right here will have 1. And so we need to know carbon and hydrogen. So carbon is going to be right here, and hydrogen is going to be right here. So we need to know that carbon is going to have 4 valence electrons, and hydrogen will have 1 valence electron. So knowing that information, let's go back to the problem. So the problem says that we have a carbon right here and then a hydrogen right here. And because it has carbon and then hydrogen and then carbon, carbon, hydrogen, that tells me that this carbon right here is going to be bonded to this hydrogen right here. And so I'm going to put the carbon down right here. And we know it's got 4 valence electrons. So I'm going to imagine I have a box around this carbon right here. And I'm going to space out these dots as much as I can around this, this square right here. And the trick is that each side of this box can only have 2 dots. And so because I have 4 valence electrons, I'm going to put 1, 2, 3, and then 4. And what I want to do is I want to have a bond where another electron can bond to this dot here, and this side of this box right here, this top part of this imaginary box, will have 2 dots. And so I have a hydrogen right here that has got 1 dot, and I have 3 of them. So I'm going to put a hydrogen here, and then I'm going to put a dot. I'm going to put a hydrogen here with 1 dot, and hydrogen here with 1 dot, because it has 1 valence electron. And so now what I can do is, this top dot right here can make a bond with this dot from this hydrogen, and then this top part of this box here for carbon will have 1 here and then a 1 here for the number of valence electrons. So this side of the box would have 2 valence electrons. And we can do the same thing for this side. This side would have 2 dots. You have 1 and then 2. And then this side right here, the bottom part, would have 1 here and then 1 here. And then we have a carbon right here that I'm going to put here. And so it's can also have 4 valence electrons. So I'm going to put 1, 2, 3, and then 4. And then this dot here and this dot here can form a bond. And so this dot and this dot would be the right part of this imaginary box right here. And so this carbon here is going to have 8 valence electrons that are going to be shared between the carbon and the hydrogen. And so I can have 1, 2, 3, 4, 5, 6, 7, 8. And so this carbon here follows what's called the octet rule. And hydrogen right here does not follow that rule. This hydrogen right here is going to just have 2 dots, a 1 and a 2. And that's because the hydrogen right here, the outer shell is going to be just the 1s. And this carbon right here, it's got an S and a P. And so all the outer shells of carbon and hydrogen are full. But for this carbon right here, we still have to work on it. So we have a carbon and then another carbon. So what I'm going to do is I'm going to put the other carbon down here. So this carbon here is going to be right in there. And this carbon right here would be this carbon there. And this carbon here would be that carbon right there. And so it's this carbon right here has 4 valence electrons. So I'm going to do 1, 2, 3, 4. And what I'm going to do now is I'm going to bond this electron and this one together. This one and this one will get bonded together. This one and this one will get bonded together. And so you can see that I just have this one more valence electron on this carbon here that needs to have a bond. And so I have a hydrogen right here, so I'm going to put down the hydrogen here, and I'm going to have a 1 dot there, and then I'm going to bond this with this, and now everything is bonded up. And so what I'm going to do is I'm going to redraw this, but I'll make it look a little bit neater. And so I'm going to have a carbon right here, and it's got a bond to this hydrogen here, so I'm going to put a line and then an H there. I'm going to do a line right here to represent this bond right here, and then this H right here would be right here. This bond right here would go down here and form that bond there, and this bond here would be this right here to a carbon. Now this carbon and this carbon, it has 1, 2, 3 bonds between this one and this one, so I'm going to do 1, 2, 3 bonds to this carbon there, and then this carbon here, which is right here, has just one bond to this H right here, so I'm going to do a bond to that H there. And so this is what the Lewis structure looks like for this chemical compound right here. And so what I need to do is I need to figure out the orbital hybridization around the central carbon. And so the central carbon is going to be right here. And so I got to figure out what this hybridization is. Now to figure out the hybridization of this, I need to know the number of domains. And a domain, the way you know those is that's going to be either a lone pair, or it can be a bond. And the type of bond that it can be is going to be a single, double, or triple. So any type of bond would count as just one domain. And so if I go around this carbon right here and see how many domains I can end up counting, I have a bond here, and then I have a triple bond here. Now, this bond here and this bond here counts as just one domain each. So this carbon right here is going to have 2 domains. So I'm going to write 2 domains here. Now, if it's got 2 domains, that means that I need to have an s orbital and hybridize with a p orbital, and it's got 2 domains, so I have one s and then I have one p, and so this would be an sp hybridization, and so the answer choice would be A.